Energy efficiency in buildings. A building envelope has two major parts. The first are the walls and the roof. Second are the windows. If the temperature outside, T out, is higher than the temperature inside, Ti, then heat transfer through the building envelopes by means of, first, conduction through the walls and roof. Also, heat transfer through the building envelopes by means of radiation and conduction through the glass window. Heat transfer by conduction. Consider the heat transfer through a concrete wall by means of conduction due to the temperature difference. The rate of heat flow Q over T depends on material. Also, it depends on the area and the thickness. Also, it depends on the temperature difference. Theoretically, the rate of heat flow Q over T proportional to the area, inversely proportional to the thickness, proportional to the temperature difference, therefore, Q over T, the rate of heat flow, proportional to A T naught minus Ti over D. When the material is also considered, the rate of heat flow Q over T equal to Ka times T naught minus Ti over D, where K we call the thermal conductivity with unit watts per meter per K, and K only depends on what type of material is being used. Note that metal conducts heat faster than insulator. Therefore, metals have higher thermal conductivity than insulator. If the room is hotter than outside, the same equation, Q over T, is used to find the rate of heat transfer or heat flow to outside by means of conduction. Let's look at some examples of thermal conductivity. For the material and thermal conductivity, for air, K is equal to 0.025. For glass, it is 1.1. For concrete, it is 1.7. And for copper, it is 401. Among these four materials, copper is the best heat conductor. Therefore, it has the greatest thermal conductivity. And air is the best insulator. Therefore, it has the smallest thermal conductivity. Example 1. We have Ti and T naught, K, D, and A. Therefore, we have rate of conduction through the wall Q over T equal to Ka. T naught minus Ti over D equal to 1.2 times 25 times 30 minus 20 over 0.08 because we have to change D into meter, which is equal to 3750 watts. What is thermal transmittance or U value? U value of a building material is defined as U equal to thermal conductivity over thickness, that is U equal to K over D. Since Q over T equal to Ka over D times T hot minus T cold, therefore we have Q over T, rate of heat transfer, equal to U A times T hot minus T cold. Therefore, thermal transmittancy U value denotes the rate of heat transfer by conduction per unit cross-sectional area per unit temperature difference. Note that U value depends on both the thermal conductivity K and the thickness of the wall. A smaller U value means a slower rate of heat transmitted to or by a building through conduction. Why do we use thermal transmittancy U value instead of thermal conductivity K? It is because many building materials have complex structure, such as a double glazed window. Therefore, it is better to consider the thermal transmittancy instead of thermal conductivity. Let's see some examples. The building components. If we have 25 mm cement, the U value will be 7.25 watt per meter square per K. For 50 mm concrete tile, the thermal transmittancy U value will be 87 watt per meter square per K. For a 50 mm insulated wall, the U value will be 0.25 watt per meter square per K. Example 2. The total area of the windows are A equal to 2 times 1 times 2 equal to 4 meters square. Temperature inside, temperature outside, and the U value. Therefore, the rate of heat transfer Q over T through the windows by conduction equal to UA delta T equal to 3.2 times 4 times 32 minus 20, which is equal to 154 watts. Average U value. If a building has two types of materials for the wall, the first is the glass windows with U values U1 and area A1. Also, it has concrete with U values U2 and area A2. Then, the average U value for the building would be equal to U average equal to U1 A1 plus U2 A2 over A1 plus A2. Example 3. The total area of the wall and roof is A1 equal to 4 times 800 plus 100, which is equal to 3,300 meters square. The total area of the glass windows are A2 equal to 200 times 1 equal to 200 meters square. Hence, the average U value for the buildings would be equal to U1 A1 plus U2 A2 over A1 plus A2 equal to 2 times 3300 plus 5 times 200 over 3300 plus 200, which is equal to 2.17 watt per meter square per K. What is meant by overall thermal transfer value, OTTU? Let's consider a building which composed of walls and glass windows. First, the weight of heat gained by conduction through the walls and windows are denoted as QC over T. Second, we have weight of heat gained by radiation through the windows and denote this by QR over T. OTTV of a building envelope is the average weight of heat gain per unit area of the wall. That means mathematically OTTV equal to weight of heat transfer by conduction plus weight of heat transfer by radiation over the total area A. According to the law, OTTV should not exceed a certain limit for different kinds of buildings. For example, the OTTV for buildings tower should not exceed 30 watt per meter square. Example 3. First, the weight of heat transfer by conduction by the walls equal to U1 A1 delta T, which is equal to 7 times 300 times 35 minus 24, which is equal to 23,100 watts. Also, the weight of heat transfer by conduction through the windows equal to U2 A2 delta T, which is equal to 5 times 60 times 55 minus 24, which is equal to 3,300 watts. Part A, OTTV of the buildings is equal to the total weight of heat transferred by conduction plus the weight of heat transfer by radiation over the total area, which is equal to 23,100 plus 3,300 plus the weight of heat transfer by radiations per unit area is 200. Therefore, the rate of heat transfer by radiation is 200 times the total area of the window, 60, over the total area is 300 plus 60. Therefore, OTTV of the building equal to 106 watt per meter square. For part B, since the OTTV of the building is larger than 30, therefore the building does not obey the regulation. How does heat transfer through windows? First, heat can be transferred through windows by means of conduction. Due to temperature difference, the rate of heat transfer by conduction in a window is Q over T equal to UA delta T. Also, heat can be transferred through windows by means of radiation. That means mainly due to infrared radiation. Since infrared carries heat, let's see how to reduce the rate of heat flow from outside the hot region to the inside the cold region through the windows. First, to reduce heat transfers by conduction through the windows of smaller U values should be chosen. Also, to reduce heat transfers through the windows by means of radiations, we have different methods. Let's consider the following suggestions. First, we may use low emissivity glass, or we say low E glass. A low E glass allows visible light to pass through, so the brightness of the interior parts will be unchanged. But the low E glass will reflect the invisible infrared radiation from outside. Therefore, the energy consumption for the air conditioning in the inside parts can be reduced. Note that low E glass is made by a thin metal coating on the outside surface of the window. A double glazing windows with low E glass can greatly reduce the rate of heat transfer through the windows by conduction and radiation. We can also use solar control window film. A solar control window film and low E glass are similar in that solar control window film allow visible light to penetrate the windows, but it reflects infrared radiation and ultraviolet. Note that for solar control window film, the visibility of the window can be chosen by using window film of different ranges from 0 to 1. The lower the value, the less amount of visible light penetrate. That means the lower the value, the darker the windows and the interior parts is. The third material can be used is reflective glass. Reflective glass is coated with a thin film of material. However, the reflective glass reflects both visible light and infrared. Note that reflective glass has two disadvantages. The first disadvantage is that the light intensity inside the room is smaller. Therefore, additional lighting is needed. That means you may consume more energy. Also, the reflected visible light will produce glare on the street. Also, we may use double glazing windows. A double glazing window contains a layer of air between two glass plates. Since air is a bad heat conductor and has a low U value, therefore the rate of heat transferred by conduction through the window is small. Notice that the layer of air inside the double glazing window should be thin in order to minimize the heat transfer by convection. Lastly, we may also use curtains or blinds. Curtains or blinds will block the light directly. However, this will make the interior to be dark.